When considering making the hop from the blue planet to the red, many of us focus on whether it is technologically feasible to make the journey and land safely. And there's the tricky bit about returning. But even if we crack all of these steps, there may be other restrictions to whether or not it is possible to travel to Mars or even further afield, namely if our bodies can physically take it. New research has found that as we escape the force of gravity pushing down on us, our brains start to change. From altered vision to increased pressure on the brain when in microgravity, the symptoms all come under a condition known as visual impairment intracranial pressure syndrome, or VIAP. But until now, the causes were unknown. This, it almost goes without saying, is a pretty major issue for astronauts. The fact that even astronauts in microgravity for relatively short periods of time on the ISS experience the symptoms means that it's likely to be a serious problem for more extended space flights. As such, NASA has made determining the causes of VIAP a top priority. Exposure to the space environment has permanent effects on humans that we simply do not understand. Explained Donna Roberts, a neuroradiologist who has been studying VIAP for the past decade or so and co-author of this latest paper published in the New England Journal of Medicine. What astronauts experience in space must be mitigated to produce safer space travel for the public. Roberts has found, through tests on patients on Earth in simulated microgravity, think lying down for 90 days with your head tilted downwards, and 34 astronauts returning from the ISS after both short and long duration flights, that the brain changes its structure. She has discovered that when in microgravity, the brain's incredible neuroplasticity means that its shape alters, along with the fact that it effectively gets squished towards the top of the skull. This reduces the amount of protective fluid surrounding the brain, which could, in turn, lead to serious health problems, such as VIAP, although more work needs to go into determining exactly what the outcome of the changes are. These are the sorts of questions that need to be answered if humans are to make it to Mars, where astronauts would likely be exposed to microgravity for at least 3 years. These are the questions that we are interested in addressing, especially what happens to the human brain and brain function. Thanks for your watching. Please share this video and don't forget to subscribe.